Greetings, everyone. So, we are going to be checking out the modules in a normal EV. So, this is a general example. So, this is a poster which has been designed by this following team, consisting of Atul, Bhushan, Dhruvik, and Midhun. So, I am Midhun, and I'm going to be explaining a few parts, and then followed by my colleague Dhruvik. So for an EV, we see that usually the power flow happens in this following example. In that we have the energy resource, and which is linked to your battery management system, and the battery management system is the module which is basically linking your loads with your battery pack, and tries to and basically takes your vehicle inputs which are provided by your driver, and does the power flow in this following way, as you can see. So based on your battery management system, so it can also provide regeneration if it supports that. So as you can see, this is the model for that. And the energy resource can again be from a different assortment of sources, whereas your loads, the vehicle loads, can be either the motor, the lights, or the actuators. Coming to the energy resource that is used to charge the electric vehicle, we see that it can be broadly classified into a grid resource, or from a generator, or as a renewable source. So what we see is that grid is usually the traditional way in which we charge all our household appliances, as well as in most cases the electric vehicles as well. So there are definitely advantages and disadvantages with all these. So in the grid, we see that the main advantage is that it has a stable power delivery, that is because of the inertia of the grid and all. So you basically don't see any fluctuations in the power output, and that means the voltage also remains constant, more or less. And we also see that since grid is owned by your electricity boards, so they can be cheaper because they are for the masses, and you can get power at subsidized rates. Then the disadvantages are that most of the grids still in our country work on non-renewable sources like coal and natural gas. So we see that this obviously has a negative impact, even though we are using an EV, and since EV is touted to be a green vehicle, so using the grid basically compromises those advantages which happen. So, and the other thing is obviously that it is a stationary power resource, so you can only charge it at specific locations. Now, coming to the generator, the advantage is that it can be mobile as well as stationary. So it can be it is more suited for emergency applications, and it also is non-renewable, and it can also have can also have a more polluting effect, basically. Coming to the renewable sources, this is what we could consider as going forward what the EVs would usually be recharged with. So we see that renewable sources right now are usually used in microgrids and all, where they are used with different renewable resources combined together, so that the main disadvantage of renewable sources is that we see the power output can be erratic because of availability, because we see like for example solar or wind, we see that it's not uniform throughout the day. and throughout the year also. So due to that reason, it is usually used in a microgrid configuration. And obviously, using renewable resources means that you are maximizing the advantages of EVs the most. Then also there are a lot of options to choose from for renewable resources based on the location and based on the availability. And you also can have charging stations which are at remote locations, which are not connected to which are completely standalone. So they can work with little to no maintenance. Now coming to a little bit of an expansion on the renewable sources itself, we see that mostly in our country we use these two renewable sources the most. So solar, we usually go for the photovoltaic type, where it requires a lot of area for your fixing or basically implementing solar panels. And also the main requirement is that it should have the area should be receiving a very good annual insolation. So also the efficiencies usually that we see in solar panels is of the order of 20%, and in some rare occasions where if all the ideal conditions are met, it can also reach values of up to 40%. Then there are no moving parts, so because of that there is no maintenance really required, except for maybe cleaning the panels. Then coming to the wind, we know that there are wind turbines which are used. They need to be in a suitable spot where the wind speeds are average around 12 to 14 km/h throughout the year, to basically because they are basically capital intensive. That is, they require a lot of money to basically set it up. And also the main disadvantage is sometimes the areas, the houses which are in the vicinity can have. There are many studies which have been done which show that there's the noise pollution, and that these wind turbines cause can be inconvenient to some people. Coming to different charging connectors that are used in EVs. So this is where your resource is basically connected to your EV. So the most common one is the CCS type 2, which is very popular in Europe, and many of the other charging solutions have been derived from CCS. So this also has a wide variety of charging systems that can use this connector. That is, you can either use AC, single phase and three phase, or else you can also have DC fast charging through these. So they can go all the way from 3 kilowatt all the way to 150 kilowatt for DC, and they are very versatile in that. So next is your Bharat EV, which is based off of your IEC 60309. And what this is usually used in small vehicles, like for example auto rickshaws and two-wheelers, and they are normal AC chargers, like the ones which we see, the three pin ones, and they can go up to 3 kilowatt for normal charging. Next is the Bharat EV, which is based off of IEC 62196, and it is also called as the type 2 charger, and this is derived from your CCS type. So here we again see this is used for AC fast charging as well as DC level 2 charging. So this means that it can support up to 22 kilowatt of fast charging. Then the other one is the GBT connector. This is very popular in China. They introduced this, and it is also becoming popular with electric buses in India. So this connector is this connector also is popular with heavy vehicles basically. Now we see that now what we just saw was the energy resource part. Now we see the energy resource has to be connected to our electric vehicle basically for charging, and this is taken care of by your battery management system. So we'll be looking into what is the use of basically having a battery management system, and what are its functions basically. So we see that the primary aim of the battery management system really is to maintain the proper functioning of the battery pack. So we see that there are a lot of pointers under this, that is to maximize the life of the individual cell, because we know that all cells are not equal. So even right after manufacturing, all the parameters are not exactly same, and it's impossible to have them to be same. So that is where battery management system comes in, and it tries to maintain that uniformity. Now it tries to bring that uniformity into the circuit by maintaining the charge levels on each of these cells, individual cells. So next is the SOC determination algorithm, because we have to know how much or what is the level of the charge that is stored in the batteries. So different SOC algorithms exist, like where the very common one is the Coulomb counting method. So such algorithms are also implemented in the battery management system itself, and that helps in understanding what is your charge state in your battery. Then you have the protection of cells. This is also very important, because there are a lot of ways in which your battery can degrade, or even in worst cases can cause a hazard. So we see protection of cells might be in different ways. Like for example, it could be your overcharge or over temperature based protection. Then we have the charging rates of individual cells have to be controlled. So the cell balancing, that is again like I mentioned before, the all cells are not equal. So you have to maintain the charging rates such that once the battery is charged basically to 100%, we can say that each of the individual cells are charged at 100% uniformly. So there shouldn't be a cell that is not completely charged, or the same applies when you are discharging, so that basically the life of the battery will be maximized. Then we have temperature management. So this, up to a certain extent, the battery management system itself can handle, but usually we can have the battery management system itself handle other cooling solutions. Like for example, if you have a cooling fan or something, so it can be handled by the control of that fan can be handled by the battery management system also. Then we have the communication. So like we know, we have our driver and the vehicle. So based on the driver's inputs, you have to maintain the power flow of the battery to the vehicle, or vice versa, and that is again maintained by your battery management system. And then it can also provide support for regeneration and for the different charging systems that I mentioned before. So we see that not all the battery management systems are the same. So based on the selection criteria, it differs on what you exactly need from the battery management system. So if you are also including regeneration also, then you would have to consider a battery management system that is that basically supports bidirectional power. So all these functions are handled by your BMS. Coming to the different components in the which are basically the modules which are inside your BMS, we see that we have the power delivery unit, the measurement unit, the communication, and the central processing. So power delivery unit handles the power flow direction from the battery to the battery to your vehicle, or from the vehicle to the battery, and also while charging. So this unit basically consists of different several FETs and their gate driver circuits. And then we have the measurement. So the measurement unit has different analog to digital converters, which measure your voltage, temperature, and the currents. And then you have the communication, which is handled by either through the CAN network, and we have RS-232, which is a popular method which is used for connection to different modules, and that can also be implemented. Then the central processing. So here is where your algorithms and your communication basically happens. So basically the brain of the BMS itself is in the central processor. Now the different components which are used in these different blocks, we see that we have in the power delivery unit, we have FETs and so FETs are the field effect transistors. So we have them and their drivers. Since they have a gate, we have to drive those, and that is done by the power delivery unit. Then in the measurement and protection unit, based on what we are measuring, we can have different sort of components which are used. So ADCs, or the fuel gauge ICs, they are also called as fuel gauge ICs, and these are used to measure your SOC levels and the power flow that is happening. So it can measure the current discharge. Then we have sense resistors. These are basically a very low value of resistors which are used for sensing the current, and these are also used for measurement. Then we have bypass FETs and current limiting resistors. These are the protection side. So bypass FETs are used for cell balancing applications. So they can bypass certain cells if they are already charged and try to redirect the flow of energy from one cell to the other cell. Then we have thermistors. So these, as we know, they change the resistance value based on the temperature, and these are also used for temperature based protection. Then FPGA and MCUs are basically, FPGA is the field programmable gate array, and MCUs are microcontrollers which are used basically to control all these different measurement sensors which we use. Then in auxiliaries, we have to have a real-time clock inside our the BMS system, which takes the measure of your time. Then we have a memory in which we have our algorithms which are stored, and also acts as a buffer to store different different values in them. And we have a voltage regulator which is used to keep a constant voltage across the battery management system so that it stays safe. So from all these, from what we saw was the battery management system as well as our energy resources. And my the further slides, further section, different blocks will be explained by my colleague 𝘠𝑢𝑣𝑖𝑘.
Hello everyone, this is 𝘠𝑢𝑣𝑖𝑘, and I'll be taking the next block and next flow of this circuit. So after battery management system, we'll move on to the battery part. So what exactly happens at the battery part? First we'll see the generalized battery reactions, so like charging and discharging. So here we can see in the discharging, the first of all, the reaction is happening at anode, which is oxidation, and it will lose an electron, and through the electrolyte it will reach to the cathode, and the reduction happens. And similarly in charging, first of all, a reverse reaction will happen, like at cathode the oxidation will happen, and at anode the reduction will happen. Now I'll move on to the different kind of measurements parameter of the battery. So if you move on to the next part, so we'll have a operating temperature we can measure. We can measure maximum C rate, internal resistance, and we can also measure the OCV, open circuit voltage. From this, we can have different parameters like power density, energy density, and rest of the parameters, so that we can have an idea with this measurement that what kind of battery it is, how much discharging rate, and what is the terminal voltage, and we can also measure the maximum operating conditions with different kinds of test facilities. So this can be useful in case if it is unknown circuit, or if it is not labeled like that. And if we move on to the battery selection criteria, so we have certain kinds of batteries which we can see in the table: uh, lead acid battery, nickel cadmium battery, nickel metal hydride batteries, and lithium ion batteries. So lead acid batteries generally we use for high powers. In case of nickel cadmium, it is high power and for long usage. And in case of nickel metal hydride, we have high capacity and long usage. And similarly, lithium ion batteries. So if we see the positives and negatives of the lead acid batteries, like advantages and disadvantages. So lead acid batteries is simple and it's low in cost. It has a high discharge current and low self discharge rate. It also has a low temperature, and it has good performance at low temperature. And if we talk about disadvantages, it has a low specific energy, and generally we can say it's a poor energy to weight ratio. Uh, it it also takes a long time for the charging, and the material used in this battery could be the toxic for environment, and it also has a limited cycle life. So if we move on to the nickel cadmium, it is fast, simple, and it has good cycles and cell life. It is also it also provides good load performance over temperature in case of high load and operating temperature. It is also economical, and it is safe to store, and it is also safe to transport and all these things. But the disadvantages we have in nickel cadmium battery is it has low specific energy, a memory effect. It also uses toxic material, and it has a high self discharge rate. Moving on to the nickel metal hydride, it has a 40% more capacity as compared to nickel cadmium battery. It is also simple in storage and transport. It is environmental friendly. It doesn't have toxic material at all, and nickel content makes recycling and profitable. So we can recycle this battery, and it could be a profitable. But disadvantages we got for nickel metal hydride battery is it has limited cycle life. It has complex charging structure. Uh, if it is a overcharge, it can deliver a poor performance, or maybe affect its life. And it also generate heat at high discharge rate, and it is temperature sensitive, as we can see. Now moving on to the lithium ion battery. So we got plenty of advantages here, like it has a high discharge, a high energy density, uh, low self discharge rate. Also is it's good to maintain this battery. It has a low maintenance, no memory effect, and no periodic discharge need. Uh, we can use as per our convenient. And the disadvantages we got here is required protection circuit uh, to to for the safety issues, and it is subjected to aging. So this was all about a battery side, and we discussed about charging, discharging, battery selection parameters, and battery identification parameters. Uh, Now, if we move to the flow chart, we got a loads, different types of loads in automobiles. So as we can see in our flow chart, uh, 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 we have motors, lights, and actuators. So we'll move on to the load. So we can define load as it's electrical load in which electrical components or portion of a circuit that consumes electric power. So we have power from battery, and we have components, kinds of components connected in the circuit. So it consumes electric power in the circuit. So we can define it as a load. So mainly we have three types of load in the circuit: uh, resistive, capacitive, and inductive loads. So these these three loads are the main types of load in the circuit. Now moving on, how we can identify these loads. Uh, uh, we can identify these loads in case there is nothing given in the circuit. So we can identify if it by the schematic diagram. It is if it is given, and if it is not there, then we can identify it as per the connections, as per the wire connections. As per Indian standards, for the single phase of load, we have a single phase line which is red in color. So this was the old identifications, old marks of this wire color. So black suggests it is a neutral one, and if it is ground, it will in a green color. So as per new color code, we have brown for the single phase line, and for the neutral we got blue color of the wire, and green remains same in case of ground. Now if it is a three phase connection, so we may identify red color as line 1, uh, yellow color for line 2, and blue color for line 3, and black color for the neutral one. And in case of ground or earthing, we have pure green color, and we can also have a mix of green and yellow color. So it suggests it is a ground. So this was all about identifications. This was the one method, and we can identify with the help of colors. Now we'll move on to the classification of loads in a EVs. So for a resistive kind of load, we can consider heaters, hot filaments of lamp, and glow plug in the engines, which is generally for IC engines and hybrid vehicles. And for the inductive, we have a main component which is motor, fuel pump, solenoid valves, different kinds of coils, relay coils, and cooling fan that we can consider under the inductive kind of loads. Now, for the capacitive loads, we have lamp filament in a cold state, filter capacitor used in various electronic circuits for filtering and uh, uh, cleaning purpose. And we can also have an infotainment system which consists of a touch screen. So we can consider these kinds of loads in capacitive loads. So this was all about our poster presentation, which was a part of our assignments. And we discussed about energy resources, and then battery management system, battery packs, and loads. So these all are interconnected in automotive and EVs. So this was all about our assignments. Thanks for listening, and have a great day ahead. Thank you.